Now, here's how we figure out which of the two conversion units to write. I want to match the starting units and species in the top of this fraction with the bottom down here. Yes, correct. So the side of the equality statement that has the same units and species is this side. So we're going to put 56.1056 grams of KOH on the bottom. That's how you figure out which one of the two to use. Then the 1 mole goes on the top.
Okay.
Mm-hmm.
Can you repeat how you got the 3.00?
Yeah, I gave it to you.
Okay, alright.
This is the problem. If we were doing a lab, this would be the amount you measured out. Okay? And by the way, on Monday, that's what you'll be doing. Got it? A lab. And on Monday, you'll be weighing out your own starting amount. Okay? All right. So, let's see. Multiplying by 1 gives you the same answer. Dividing by 1 gives you the same answer. So, really, the fast way to solve this is this divided by that. Okay? So, plug in your calculators and let's see what kind of answer we get. Practice, 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 because practice makes perfect. Good. And perfect practice makes perfect results.
But nobody's perfect.
Ah, but we're striving for perfection in here, aren't we? We are going to strive for perfection. Okay? Ask about that in your Sunday school class. And I hope I haven't offended anybody that doesn't have a Sunday school class. Most of you do. That's why I use that as a reference. Yes. Were you not paying attention? All right. Why did I round it off there? I need 3 significant digits because that's the smallest measured or calculated number in the problem. Leading zeros are not significant. The 5 is the first significant digit. 1, 2, 3 digits are significant. So we get 0.0535 moles of KOH. Alrighty. That's step number 1.
That's all step number 1?
Yeah.
Step number 1?
Yeah. See, which we haven't even got. We've only got moles of KOH. We're trying to find the mass of something else. That's right. Okay? All right. This then is your starting amount for step 2. Starting amounts go where? On the top, over 1. 0.0535 moles of KOH over the number 1. Not 1 gram, not 1 mole, not 1 liter, not 1 Fernando, but just the number 1. Okay. Okay. The number we calculated here becomes the starting amount for this problem. Okay. Now, to go from moles of one species to moles of the other, this is what we learned to do yesterday. Moles of one species to moles of another, we have to have a molar ratio. And where do molar ratios come from? Balanced equations. Coefficients. Okay? Yeah, this is molar mass conversions. This is the molar ratio down here. So we want to get from KOH to aluminum hydroxide. The 2 different species. KOH here, aluminum hydroxide here. The only way to get there is using the coefficients in a balanced equation for a molar ratio. So, down here on the bottom, again, it's always matching the units and species in the top of the previous step. Okay? So I want moles of KOH down here. And how many do I use? 3, because that's what's in the equation. Up here on the top. Alright, if I'm trying to get to aluminum hydroxide, then I want moles of aluminum hydroxide on the top.
If that's what you're trying to get to, then that's what you want on the top?
Yes. And so how many aluminum hydroxides do I need? 1. I'm sorry, I made a little squiggly thing here. I was a little marking error here on my part. That's not part. It's not okay? I'm so sorry. Alright. What kind of math operation do you do here? Not cross multiply. That happens when you're... Okay, got to mark out some stuff. Oh, we didn't mark out our units and species up here, did we? Oh, no. Oh, no. You're supposed to...
Yes.
Listen. Listen, listen. Shh. I'm so used to doing this. Sometimes I skip steps in my brain. You need to cancel units and species so you can keep up with everything.
That's what I did earlier, and I said it out loud.
I'm sorry, Fernando. I apologize. All right. So, tell me, Fernando, what do I do here? What? You just told me that. You claim you knew it. Man. Were you lying to me, Fernando? Okay. At least you're honest about lying. So are you lying now or were you lying before? Okay. 0.0178. 3, and it keeps on going, doesn't it? Okay. And that's moles of KOH. We need to round that off to how many? How many digits do we round it off to?
I thought we were looking for ALOH.
Oh, I am. Boy, I am really having trouble today. No, that's right. KOH is right. I'm looking for this. That should be ALOH sub 3. You're right. All right, look. I'm trying to be patient with you guys, okay? But there are some folks in here who I won't name out loud unless I have to, that are just talking away. And it is really hard for me to concentrate. I can't imagine how hard it is for students that really want to understand. Okay? Now, I make enough mistakes anyway, and you guys are helping me keep me straight. I appreciate that. But, it's just worse when you make it harder on people. All right, now, how many significant digits do we need?
We need
3. Leading zeros are not significant. So these 2 digits are not significant. Neither are these 2. 1, 2, 3. All the 3s go away. You're right. All right. Step 2 is done. 3 steps. So this becomes our new starting amount. You put it over 1. Okay, let's kind of review just a little bit. Let's talk about where we've been. All right? We started out with the mass of potassium hydroxide. We calculated the molar mass to get to moles of that starting species. Okay? So that got us to Moleville. And then while we're in Moleville, we can convert from the moles of what we started with to moles of what we're trying to find using this molar ratio. And the molar ratio comes from the balanced equation. Okay? So now we have moles of the thing we're trying to find. So now that thing we're trying to find, the moles of the thing we're trying to find is down here over 1. And we've got to get from moles of this to the mass of this. And what do you use to go from moles to mass? And what equality statement do we calculate? No, we're going to calculate the molar mass. Another molar mass. This time's for aluminum hydroxide. Okay? So what's the atomic mass for aluminum? how many aluminums in the formula? 1. And the atomic mass for oxygen, 15.9994. And we have how many oxygens in aluminum hydroxide? 3. And that becomes 47. You know, if you were plugging this in your calculator as I walk through this thing, you'll be so much better prepared for the test. And if you're just sitting around and copying answers, that doesn't really help you much with the test. Hydrogen, 1.00794. How many of those do we have? 3. No, 0.2. I wrote the wrong thing. It's 0.2. Yeah, I wrote down 2 zeros when I only need 1 zero here. Zero 2 382. Okay, and we should see there are 2 empty slots, or 2 columns with empty slots. Well, you put on your paper. You know, you can just look at the numbers yourself. I mean, I'm trying to get it all on one sheet of paper here, and it's a lot of calculations. Because there's 2 columns with empty slots to the right, we're going to round off the last 2 digits to the right. And we have 78.0036 grams of aluminum hydroxide equals 1 mole of aluminum hydroxide. That's right. So if I've got moles of aluminum hydroxide on the top here, exactly, 1 mole of aluminum hydroxide needs to go on the bottom here. And the other side of that equality statement I created here goes on the top. No.